All right, on the set part coming up, number 7, 8, and 9 are all talking about 5x squared. So let's start a quick diagram for all of these and see if it will help us. 5x squared. Oh, these are definitely not squares. Let's see if I can find a little shape here. Okay, there's my 5x squareds. Now the first one has 30 x's. So imagine that I have to put little x's along the sides and the bottoms here to match, and I need to make sure that there's 30 split between all 5. Well, take that 30 and split it by 5, and that gives me 6 little x's that need to be on each one. So if it's 6 x's on each square, on each diagram, then it's going to have to split that in half for the square sides, like 3 on this side and 3 on this side. 3 on this side and 3 on this side. Okay, so if I did that and split 3, 3, 3, 3, 3, 3, these all have x plus 3's on the side and the top and the bottom, etc. So this is going to become the 5x plus 3 squareds. And now I just need to look, how many of our little constants does that give us? So right here, there's 9, 9, 9, 9, and 9, because of all of these 3 times 3's. You got it. 9 times 5 is 45. So find the missing constant so that each expression represents 5 perfect squares. I need to do 5 times this 9, or 45. Well, the next two are also 5x squareds, but instead of having a middle term of 30 to split up between the 5 squares, we now have a middle term of 50 to fit up between the 5x squareds. So without drawing out all these pictures, can you figure that out? Pause it and try it. Anyways, 50 divided by 5 would be 10. 10 gets split up to 5 and 5, or 25 in each square. So up here was 9 times 5. Here is going to be 25 times 5. You got it. And then what does that break out to be? That's the 5 times x plus 3 squared. And this one's going to be the 5 times x minus 5 squared. All right, pause it and try the last one on your own. Okay, 10 has to get split up by 5 squares. So 10 divided by 5 is 2. And 2 has to get split in half for each side of the square. So it's really just going to be an x extended by 1 on each side. And that's going to be 1, 2, 3, 4, 5 total in our constants in the bottom of all of those. If that was confusing for you and you want to come by and have me show you kind of drawing out the diagram on each one, feel free. All right, next one, write 2 equivalent equations for this one. Here's my x by x or x squared. Here's my x by x or x squared. So it means we have a total of 2 x squareds. 1x, 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 plus 4x, 1, 2, 3, 4, 5, plus 5. So this is the standard form that I can just go ahead and count those up. But now let's break it up into a perfect square. If I had 2 x squareds and I have a total of 4 to split between those, do you see how it's only going to be 2 on each one? So picture, let me do a little diagram over here. Picture that I'm taking my x by x from over here, and I'm splitting these up between the two. So 1, 2, 3, 4. There's my 4 x's. And then that only leaves me 1, 2 little constants. So for the other format of how to write this, there's 2x squareds. X plus 1 squared is what I ended up having to draw. But if I drew that, that's a 1 times 1 equals 1, 2. So that would be a plus 2. But I actually want 5 at the end there. So if this includes 2, but I want 5, how many am I missing? You got it. I want to add 3 to the end to make an adjustment for it. There's my 2 expressions. Determine below if this is a perfect square or not. If it is not a perfect square, find the perfect square that seems closest to the given expression and see how it can be adjusted to make the given expression. So for example, here we would have ax squared equals the x plus 5 squared perfect, meaning 5 and 5 make 10. Well, 5 times 5 makes 25. So I didn't want 25, I wanted 14. So I would have to subtract 11. 25 minus 11 gives me 14 off to the back side. The next one, I take out a 2 and make the adjustment. Actually, let me do this one by diagram based on how today went in class. So here I've got this square, 2 x squareds, and this has to be 16 of these. So that's 8 and 8, or 4. And then 4. And so if this is 4 by 4, that's 16. And this is 4 by 4, that makes 16. So that's actually 32. But, so we go 2 x plus 4 squared. What adjustment do I have to make if this right here makes 32, but I only want 6? I have to take away 26 from the 32 in order to get 6. Okay, last one. Let's draw this little diagram. There's 3 of these perfect squares. And then there's 18 different long ones. So that's going to be 6 on each. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now I have my 18. But that's going to be 9 plus 9 plus 9. Nine times 3 is 27, and I want negative 12. So that's going to have to be minus 39 to get us all the way down to negative 12. All right, find the indicated function value with this and this. So here, actually, I'll do this in a separate video because it's getting kind of long.